When I'm in a big city, one of my favorite things to do is stare at massive buildings and skyscrapers. Perhaps you can relate to me, but ever since I was a kid, I've always wondered how people go about making such massive buildings. Recently in China, a 57-story high-rise building was assembled in only 19 days. The reason why something like this is even remotely feasible is through a method called modular construction. Rather than doing most of the work directly at the job site, which happens in traditional construction, the building is actually constructed off-site into large parts called modules, which are then transported to site and installed together. The best way to think about this is through an analogy to Lego, where building modules are essentially massive Lego blocks designed to snap in place and stack on top of each other. What's interesting though is that modular construction can be used for more than just making skyscrapers. In fact, the entire construction industry is shifting towards modular because it's proving to be less expensive, faster, safer, and yield higher quality. But while modular construction is having this impact, there are some serious logistical challenges for making it work properly. This is where my research comes in. You see, modular construction can be a golden opportunity for constructing buildings, but only if it's done correctly. One of the single largest factors that impacts the success of a modular project is how well the modules fit together. Recently in New York, a modular construction project was completely shut down due to millions of dollars in litigation, and the reason was because the modules did not fit together properly. In traditional construction, where a building is assembled piece by piece, the connections between components are not as critical, since they can be adjusted or modified incrementally during construction. For modular, however, you essentially have one shot at getting the module connections right, and you only find out if modules fit together properly once on site ready to be installed. After spending time on different projects and seeing various kinds of module fit problems, I developed a strategy to ensure that modules will be assembled correctly. To do this, I apply theory used in aerospace and automotive manufacturing, where having a product that fits together properly is of utmost importance for proper user safety. In my approach, modules are analyzed using a laser scanner, which is capable of capturing millions of data points in a matter of minutes. This data is then fed into a framework which is used to design the module connections. In my research team, we have started to implement parts of this strategy in different projects, and have found in fact that if designed correctly, modules will be assembled properly. For modular construction to be the golden opportunity for constructing buildings, the industry needs to get their hands on vital design considerations. And my research provides that connection. No pun intended. Thank you.